In the second item on our second test, we're asked to find another force in a bar of the truss, and note that that member is this one right there, CE. Single free body diagram and the single equation of equilibrium. We don't actually have to solve for it. So we'll cut right across through there. Nice little simple method of sections. And I like this. I won't have to find what the reactions are. Don't have to worry about any of those at all. All I need to do is go write or draw the free body diagram. I want to try to get it somewhat to scale. Note that we have a somewhat symmetric structure and certainly symmetric loading here. That will turn out to be potentially very useful. We've got our two 500-pound loads. They are at the top, C and D. We've got the force in the two outer legs, DE and EC, probably in compression. We're asked to find the number CE force. We'll guess that it's in compression. It might be sort of natural to assume that. We've got everything. There's our free body diagram that we need. And if I'm going to do this with one equation, I can't do it sum of forces in the y. I can't do it sum of forces in the x. I'm going to have to use a moment equation. I want to get rid of the two unknowns that are causing the problems. That's EC and DE. So why not then extend their lines of action to a new point, G, let's call it. Note that because of the symmetry of the geometry, then that is located in the centroid of the system, or at a distance of 1.5 feet. On the other side, we've got 3 feet in the middle. Both are inclined at the same angle, so that when we go to then do our equilibrium equation, then well, some moments about G, let's take clockwise as positive, and we get then minus 500 times 1.5 plus 500 times 1.5, and then plus, ooh, did you see what's going to happen already here? We need the perpendicular distance of the number CE that is equal to 0. That's your equation of equilibrium. You can find out what that D is, but we know it's not 0, and we know that, lo and behold, those two are going to cancel each other out, and I'm not asked to find this, but CE is going to be a zero force number, which does mean that if that's 0, so is that one, so is that one. Kind of an interesting little conclusion that ended up happening, all because of the symmetry of the structure and symmetry of the loading. It actually makes sense. DE and EC are going to have equal and opposite x components in this particular situation.